Hello everyone. In this video I am going to talk about how LogStream can use Redis to manage large lookup tables. Before LogStream supported Redis, the alternative was to use CSV files or the MaxMine GeoIP lookups. As you know, in LogStream we have the master node, and then the master node relies on the worker nodes to do the work itself. But within the worker nodes, we have the concept called a worker process. The way we deal with lookup files is that upon a start, we will read these lookup files from disk and into each worker process memory. And for example, the MaxMine GeoIP lookup is approximately 60 megabytes in size, which translates to about 150 megabytes of heap size per worker process. And that with considering that each worker process by default was designed to work with 2 gigabytes of memory, which means that for very large lookup files, this kind of requirement of loading the lookup files into the worker process memory could impact LogStream available memory. So with the introduction of Redis, we have the option to use this Redis, which is an in-memory key value database. And it really enables LogStream to interact with a truly large lookup tables that could otherwise be fairly cumbersome with our CSV support or with the MaxMine lookup files. When we use Redis, we can then start considering very, very large lookup files that could be also modified on the fly. And so, for example, you could have a JSession ID table that get modified every milliseconds, and we can use that as a lookup to make sure that that LogStream it has the latest and greatest information at the time of the lookup without really the impact that otherwise will be on the worker process memory. For example, you can load in the entire Social Security numbers of the US. We have over 300 million citizens, so that could be a massive database. We can do all of those things and also make sure that Redis is up to date, and then the lookup really truly benefit from both the size processing as well as the ability for that lookup to be modified all the time. Also, another set of use cases that we can see here is that we can, within a LogStream, inside of the Redis function, we can do a set and a get, or hset, which is a hash set, and a hash get, which means that we can actually modify the Redis in-memory database from within LogStream. So this is a really nice capabilities that this integration gives us. Some website that I found very useful as you start manipulating Redis is the redis.io. Also, another website that I found very useful is around the tutorialpoint.com. There is a Redis tutorial that can give us some really nice view. For example, I wanted to set in my demo the hash set a command. So by clicking on that, it gives you several examples of what exactly is needed whenever you set this command from a LogStream. As far as configuring the Redis function itself within the LogStream master node, we can jump into a few examples. In here, we have a pipeline that is in charge of doing a VPC flow and enrich the IP with GeoIP. And in here, we can see that in this pipeline, we added the Redis functions. The Redis function is available as part of the list of functions that is available on LogStream. Once we added the Redis function, the very first thing we did here is we connected to that remote Redis database. After that, in order for us to pull the AWS account name from Redis, we used the get command. Get command is one of the many commands that are available in Redis, and the key that we told Redis to look for in the Redis database has the signature of account ID underscore the value. In this case came from the log. The AWS account value is the one that actually populate that, and once the key has been matched in the Redis database, we populate, in this case, the AWS account name field. And so that from this step down, this kind of account name is now part of the LogStream events. And to see some additional Redis options, I have a local setup of Redis that allows me to kind of experiment with some of those set or get, or with or set up some variables, or do some of the other functionalities. So in order for me to do that, I have a local installation of Redis that I can start with using the Redis server command. And I also have the Redis client available to me, so that I can, as I'm inserting information into Redis, I can actually validate some of these assumptions. So this is the Redis server and the Redis client. And again, as I mentioned earlier, I installed that locally using the yum install Redis. So with that, let's take a look at the first example. In this case, I have a Redis function that I added. I added the address, the URL address of my local installation of Redis. And what I'm doing here is I'm using the Redis set command, and I am telling Redis that the key is going to be field A, and the value is going to be 1234 or test 123. And then right below that, I used the get to retrieve that same field that I said a second ago and populate a LogStream new result field with this information. Next set of commands are the commands that deal with hash. For example, the hget, the hkeys, the hgetAll, and the hset are some of those commands that Redis makes it available to us. Once we enable this section of the pipeline and save that, we can see that the hgetAll gives us both all the keys as well as the values for this particular key, actor 912, as well as the active keys are just the keys that are associated with that, as well as you can be a little bit more granular and just get one of those key and value. The one that is a little bit different is the command called hset. Hset is basically your ability to update and insert a new value. The interesting part about this command is that it actually requires 3 parameters. It requires the keys, it requires the field, and it requires the value to be inserted into Redis. In order for us to overcome this issue, we have to feed the software with an array. And in array, in this case, I have 2 values. The very first value separated by a comma, and then the second value. And we can see that requirement in the documentation, in the Redis documentation, that shows us hset is the command, this is the key, that's the field, and this is the value. And so once we have the array with these additional parameters, we can then execute the hset command and then see inside of Redis the actor 9110 with all of its parameters. So let's do hgetAll with actor 910, and that gives us pretty much what we expected, which is in this case I just added the value of the cell phones and the social security values. The next set of commands that I was adding to LogStream is around the ability to manipulate lists. In this case, I was using the lpush, and I'm setting up a bunch of social security values into the list called SSN, as well as I'm adding a kind of the range in which I want to search in that list for the social security numbers. And once I click on save, and we can see right away that all SSNs have been manipulated was populated with a list of social security numbers. So that's the list capabilities. And with that, I'm hoping that you can leverage Redis as a way to manage your large lookups within LogStream.